Okay, so this lecture is for April 12th. We're going to have to go back and forth between our PowerPoint and our document camera. So that's where my hand is waving right here. You'll have to look in this bottom right-hand corner from time to time because I will have some demonstrations that will go along with the PowerPoint. So we are really looking at magnetism and how magnetism interacts with electricity. So let's go ahead and get started. First of all, you are going to be filling out a guided notes work with our lesson for today. And you do have a quiz that is posted as well. So that is our main thing. We are looking at our guided notes and our quiz. And then the rest of your class time can be used to be getting caught up on any missing assignments. So the word magnet comes from the word or from the actual rock that is called magnetite, or these are also called lodestones. Magnetites are naturally occurring rocks that have iron in them. So they do occur naturally within nature. And so we actually have a magnetic field that can be produced from having magnetic properties. And we know that this magnetic field exists because of our, well, let's say that we have our magnet, it's attracting the other metals, and we have little iron shavings here. And these iron shavings are creating a pattern that we can actually see as magnetic fields. Okay, so as we can see, we do have a paper clip here. And we know that metals should be attracted to magnets. Now, what we can do is you can actually create a magnet using what you have here and, a piece of metal. But let's figure out what actually is a magnet made out of. Well, magnets are made out of 3 different materials. Most commonly, magnets are going to be made out of iron. Secondly, nickel. Nickel is actually very common in our everyday objects like paper clips, pins, earrings, and stuff like that. So a lot of your everyday objects are nickel based. More of your cooking utensils and stuff like that are generally going to be iron. Cobalt, on the other hand, I can't exactly tell you right off the bat. I believe cobalt is more within the coloring of some different metals. So what we have here is a sphere, and for those of y'all trying to follow this along with the lecture, this is actually going into question number 3, looking at your different diagrams of non-magnetic materials. You have what is called magnetic domains. And if all of your magnetic domains are focused in different directions, they're eventually going to cancel each other out. And so that's actually going to be your answer for that left side for non-magnetic materials. The different domains will cancel each other out. The arrows are going in different directions. If we have a magnetic material, you will see all of the magnetic domains going in the same direction. And so again, that would be for question number 3 for that magnetic materials box. Now, magnets are made from 2 different sides, a north side and a south side. That's what the N and the S stand for. So you do have 2 different poles. Sometimes you'll see this as a positive and negative side, but we generally don't want to just say positive and negative because if you look at a battery, what we've been doing with circuits, you have a positive and a negative side with a battery, and we don't want to confuse batteries and magnets. That's why we label them differently. So you have 2 different poles on a magnet, north and south. Like will repel, and so as you see, let's put this down right here. You'll have a south and a south come together, and they will not go together nicely. They'll try to avoid each other. If you have opposites, like here's a north and a south, they will attract and they'll try to stay together. So that is actually questions 4, 5, and 6 right there. So question 7 does go over how can you make magnetic fields in different objects. So the first step is to take a magnet and a material right here. So I have a nickel-based paperclip. That's what I'm looking at. And to create my new magnet, I will simply get my existing magnet and my object made of iron, nickel, or cobalt, and I'm going to rub the object with the magnet in the same direction several times. And so if you have a magnet and a paperclip at home, you can do this yourself. So I have rubbed this right here, this paperclip, with the magnet several times. And so with what we've done is we have aligned the magnetic domains of the atoms and the object together. And so I should have created another magnet, which is why I can actually pick up the other paperclip here. Now, it is fairly weak. That is why it's not staying for a whole long time. It's because of the weight. But that's what we've done. We have made another magnet using a magnet we already had, rubbing it along right here several times in the same direction. So that way all the domains are lined up. And you should be able to use that to pick up another piece of metal. So what can we actually use this for? What have we seen? Well, the Earth is actually made from an iron core. And we know that the core of the Earth the core of the Earth is actually made out of mostly metal because of our volcano eruptions. So since we have an iron-based core, that means that we have a magnetic field around our planet. And of course, that's why we have a North Pole and a South Pole, just like with our magnets. And we can actually use devices called compasses that use magnetic north to actually direct ourselves around our globe. So make sure that you are marking this as a compasses guide you going magnetic north, not just north, because there can be a difference sometimes. All right. So let's continue on into our electromagnets. Electromagnets are basically going to combine our knowledge of circuits, which means we're going to have a power source of some kind, and our knowledge of magnets. Now, magnets are attracted to our batteries. So you know that a battery contains either iron, nickel, or cobalt in them. So an electromagnet, you are going to create a circuit. So that's why the battery is now plugged in. And I can use a copper wire. And this copper wire will transfer the electrons. And that's creating your closed circuit. Now just to show you, it is copper, I guarantee you. It is not attracted to the magnet. Copper is not one of your metals that is attracted to magnets. So I'm going to use my magnet here. You know it's attracted to the battery, which is why it is staying right there nicely. And here I am closing the circuit. And so it doesn't like to stay too much, but you're seeing the rotation. That's how you know that the electromagnetic field is there. That's how you know there's electricity going through the wire, is from this, what is called an electromagnetic generator. And so I'm going to leave this kind of running right there. So this is going to start looking at number 10. Electromagnetics are magnets that are powered by electricity. And they have an electrical wire that is surrounded in one way or another by a core of iron or steel. So this is still an electromagnet. It's just my coil is not wrapped around the center. It's using the power of the battery and the magnetic field. So I mean, there are various ways to go about your electromagnetics. So electromagnetics, when the electric current is running through the wire, a magnetic field is temporarily created. Just to kind of show you the pace, that was actually number 12 on the handout. And you are going to see what is called a battery. This is 13A, a battery. 13B is wires, because that's what you have here, a battery and wires. And you will have a core. That's what this white box is here. A core that is made of either iron or steel. And then you'll have your black coil, which that is your wires that are wrapped around each other. And this gray is showing you the magnetic field. And so that should be 13E, is looking at your magnetic field. So when you take your electromagnet, you can actually control the strength of it. And you can do this by changing the amount of electric current. If you increase your voltage, you increase your current. So all you have to do is increase your number of batteries. By increasing your number of batteries, you have increased your current, which has changed the strength of the electromagnet. You can also change the polarity of your electromagnetic. You can simply, let's take this off. All you have to do to change the polarity is take your battery out, and then, see, it was facing this way. All you have to do is flip it to go the different direction. Okay, so I kind of took out the plugs when doing this, so I'm fixing this here. So it was going this way. Now we're going to make it go this way. We're going to plug it in. And you'll see that the direction of the spin is actually about ready to change. So it's not, I'm going to kind of pull this up just a little bit. So before it was going this way, it was coming towards me, but now it is being pushed away from me. So that's showing you the direction of the current is actually changing. And last but not least, you can actually turn an electromagnetic battery. You can turn its magnetic field. You can actually turn it on and off. So if I was wanting to turn my magnetic field off, I would simply remove the battery, which is the same as flipping a switch. It would just be flipped off. If I want to turn my magnetic field on, I can put the battery back in. So if you have a magnetic field, you can simply turn the circuit on, which if you are turning the circuit on, you have a closed circuit. If you have a current that needs to be turned off, you will open the current, and then that way the magnetic field and the circuit itself will not be on. That will not work if it has an open current. So that's starting to relate electricity and our magnets here together. Now, last but not least, this is for number 17. It goes over everything here. This is a really good summary of electromagnets. And we see actually devices like speakers, electric doorbells, circuit breakers, electric instruments, and electric motors. Those are all devices that actually use electromagnets. So if you do have any questions or comments, do let me know, because as always, I will have your Google Meet open for the entire class, and I will have your GoGuardian up for the entire class. Other than that, though, you do have a quiz. Make sure you have filled out the guided notes and submit that to me as your homework. So have a wonderful Tuesday.